All right, guys, let's get started. We've already spent the time working on section 1.1. You should have done the vocab and you should have also taken care of the examples video. Let's go ahead and take care of section 1.2. Write down the title, turn to your packet where you have this information, and we're going to look at 1.2. We're going to use segments and congruence. If there's a word here like congruence, you don't know what it means, listen up. We already know what segments are. Write down today's date, whatever the date is where you're taking these notes. And remember, neatness is important. I probably should have suggested this before because after looking at your notes, I feel like you guys might need a little bit more help. You can draw a line straight down. Use a ruler, please. Draw a line straight down so you are separating the vocab from the definitions in the drawings, and that's going to be helpful for you, okay? So let's go ahead and get started with that. Let's take a moment. Let's get our first vocabulary words. Get started now. The first word, we got two words, they kind of mean the same thing, so we're going to put them together. The first word is postulate or axiom, and basically it's a rule that we accept without proof. Without proof. So we're going to just accept it. If you get a postulate, if you get an axiom, it's a rule we just need to hold on to. There's going to be other rules we're going to talk about in geometry. Those are called theorems. Those we're not going to just accept. We're going to prove them. So again, the rule that is accepted without proof, postulate or axiom. Our next word is coordinate. Coordinate refers to when you have like points on a line, right? Let's call this point A and this one point B. And you put a number next to that point. You associate that point with a number. And you've seen this pretty much all your academic life where you might see the number 3 here and the number 7 here. Those numbers that are associated with a point on a line, those are called coordinates. Numbers that are associated with a point on a line, those are called coordinates. So our next word is distance. The distance is really the space between, or the length of the space between. So I'm gonna take this, I'm gonna copy it, and I'm gonna paste it over here. Let's see if I can drag it down. And let's talk about distance in reference to this picture. So the distance between, in this case, is going to be the numerical value that I would use to associate with how far apart these 2 points are. And the way you find it is you are going to take the difference between the 2 points, but you want the absolute value of it. That part's going to be important, and we'll talk about it more. So if this were like x sub 1, let's call that x sub 1 and let's call this x sub 2. The way you would see this written in your textbook is the absolute value of x sub 2 minus x sub 1. And what that takes care of is if we are dealing with like negative numbers, it's going to make sure we get a positive answer. In this case, the distance between points A and B would be 7 minus 3. Absolute value, if you remember, just makes a thing positive. If it's already positive, it stays positive. So the distance between these 2 points is 4. So that would be the distance or the length that we would say is associated with that, all right? So the distance is the absolute value difference between 2 coordinates. That's how you would say that mathematically. Write that down, please. By the way, when you see 2 letters side by side like this, AB means the length. This word should be means. AB means the length of segment AB. And so in this case, AB, no line at the top, but it means the length of AB would be 4. Make sure you get this down. This is going to be important for your notations, okay? All right, let's go on to our next vocabulary word. That word is between. So here, I'm going to put a couple points on this line. And so if I have A, B, and right here is Q, you can clearly see that Q is between A and B. Okay, so that's what betweenness means in our class. Why am I pointing this out? Because sometimes you might be in a position where you have something like this. So if we have the same line, A and B are on that line, or line AB, right? Let me make sure I indicate that they're lines. If you had that, and then right here you had point C, we do not call that in between. We don't call that between because it's not on the line. So when we talk about betweenness of points, they have to be collinear, all right? So write this definition down and also write down those pictures, please. So here's that definition, and here's two pictures. This one, good. We know that Q is between, and this one, C is not between. When 3 points are collinear, you can say that the middle point is between. We can use that word between for that middle point. Let's go ahead with our vocabulary. Okay, so we're looking at congruent segments, and when we talk about congruent segments, here's what we have. You've got 2 segments here. Let me give some values here. Let's call this guy -3 and this one 4. And let's say that this is located at 2. A coordinate for Z would be 2, and the coordinate for W would be 9. What I'm going to ask you to do right now, and you can pause me, is to figure out what the length of XY is, what the length of segment XY is. And so we would just do X and Y with no line at the top. That means a number. And I also want you to figure out what the length of ZW is. Again, when I write Z and W together with no line, that's just talking about the length of that segment. So what's the length? I'm hoping you took the difference between these two numbers. 4 minus a -3 is 7, and then 9 minus 2 is 7 as well. We take the absolute value of the difference, and we realize that we've got both of these segments being 7 length of 7. If these segments have the same length, then you know that they are congruent. So here's what I would write, realizing that they've got the same length. I would write segment XY. Now I'm putting the line at the top so I can talk about the segment, is congruent to segment ZW. Notice the line is at the top, and I do the equal sign with a squiggly line. This sign literally means congruent, okay? So what are congruent segments? I'm glad you asked. Write this definition down, please. So the definition, segments with the same length are congruent. This symbol literally says congruent. So that's what congruent segments are. So here, the last 2 things we're going to talk about are actually postulates. Remember what postulates are from earlier in our notes? A postulate or an axiom is a rule that is accepted without proof. So we're going to give our first and second postulates of the entire year. So we're going to start off with that, make some space, and we're going to write them as definitions. So the ruler postulate is basically a postulate that says between 2 points, you can use a ruler to measure the length. Sounds basic? That's exactly what postulates and axioms are, really basic. Let me write that definition down for us. So the ruler postulate basically gives us permission to use a ruler. It says you can use a ruler to measure the distance or measure distance between 2 points. That's what we get from the ruler postulate. And I know it's really simple and it really makes sense. And it's almost like, why are we writing this? This is what geometry does. We want to make sure and be really clear about all the things that are legal and okay for us to do. And here's our last postulate we'll talk about today. This postulate is a segment addition postulate, and what it does is it requires us to have a little picture here. So I want you to make sure and get this diagram down. Here's what we've got. We've got a point A, we've got a point B, and we have point C. And here's what it says. It says, hey, AB, that's the length from here to here, plus BC, that is the length from here to here, is equal to AC, the entire length. So this is the concept we're going to play with, right? Watch this. The first part of the postulate says if AB plus BC is equal to AC, if this plus this is equal to the whole thing, then we know that B is between A and C, all right? Now this next one is going to be exact, and it's still the same postulate, but this next one is going to kind of say it in a different order. So if B is between A and C, right? If B is between A and C, then guess what? Then we know that the length of AB plus the length of BC is equal to AC. And that both of this, all of these together, both of these statements all together, that is the segment addition postulate. So that's it for our written notes. The next thing we're going to do is our examples, and we're going to do that all in one video. So let's go ahead and turn to your example section, and we're going to start with this first example. Remember, we're in section 1-2 and we're looking at example 1. It says apply the ruler postulate. Measure the length of ST. Now, if you were to measure this length, generally we'd probably start at 0, but you don't have to. If you assign 2 to S and then figured out, look carefully now, I'm going to zoom in so you guys can see better. If we were to assign 2 to S and then assign 5.1, 2, 3, 4, this is the number 5.4 to T, how can we find the length? If you remember, finding the length is finding the distance, and we're going to take the difference between these two numbers, but we're going to make sure it's the absolute value of it. 5.4 minus 2 is equal to 3.4, and the absolute value of 3.4 is just that, 3.4. Therefore, ST, remember with no line means the length, ST, the length of segment ST is 3.4. Let's look at the next example. In example 2, we're looking at a map. It says that the cities shown on the map lie approximately in a straight line. Use the given distance to find the distance from Lubbock, Texas to St. Louis, Missouri. So let's see. Lubbock, Texas to St. Louis. How can we find the distance? They gave us the distances from L to T and from T to S. So we're going to use that. What are we going to do? We're going to use the segment addition postulate, meaning this distance plus this distance would be the whole distance. So this isn't too hard for us to do. Let's go ahead and do the math. So we've got that these two distances added together will give us the length of LS. So all we have to do is really add it. And when I add them together, here's what I get. 740 miles would be the distance. So LS is equal to 740, and we get that from the segment addition postulate. Here's example 3. So example 3 is giving us that the length from F to G is 36. The length from, F to H is 36, but the length from F to G is 21. How do you think we'd find GH? I hope that you are thinking what I'm thinking. You're going to take the 36, subtract the 21, and you're going to realize that that's the length of GH. When I subtract these two values, I find out that GH is equal to 15. So the length from G to H is 15. This final example, example 4, asks us to do a little bit of graphing. So I'm going to create a coordinate plane and we're going to get started. Notice that we have an X and Y axis. X goes from left to right. Y goes up and down. I like to say Y is high. It goes up. And so now we're going to plot these points. The first point is -3, 4. That means go to -3 on the X axis and then go up 4 from there. 1, 2, 3, 4. And here's point J. Now we have to do the next one, which is K. And so we're going to start on the X-axis, go to 2, and then we're going to go up to 4. 1, 2, 3, 4. So here is K. We're going to do the rest. Going to L, we go from to the right 1 up 3. M, you go to the right 1 but down 2. And so now the question is, in a coordinate plane, then determine whether JK and LM are congruent. So let's draw JK. And let's draw LM. And let's see, do we think they're congruent? Let's count the distance between them. 1, 2, 3, 4, 5. It looks like JK has a length of 5. And 1, 2, 3, 4, 5. LM also has a length of 5. So I would say JK is indeed congruent to segment LM. And that's our final answer. I hope this made sense. We're going to talk about it in class. We'll be practicing these concepts and we will keep working. So you'll let me know how we're doing. Make sure you get your notes copied in time. I'll talk to you guys soon. Take care. Bye-bye.